Our next speaker is going to be Jelte Fennema, and he is speaking, ironically, because of the little niche museum in Simon's talk. I love that, like, here's the apology from AI for destroying the world. So, of course, up next, we need to, and this is not planned, we need to have a talk about ChatGPT and Postgres and Rust and all that. So that's fantastic. How you doing, Jelte?
I'm doing well, yeah. So
Excellent.
I'm very excited.
You're joining us from the Netherlands?
I am, yes.
Excellent. So just for those who have not met Jelte before, he's a senior software engineer at Microsoft. You work on Citus and on Postgres, and I believe you're a maintainer on PG Bouncer?
Yes, all of those.
Yeah, so we all owe you a few beers, I imagine, for that for work across the board. So excellent.
Or coffee. Coffee works too.
Or coffee, yeah.
Okay. Well, Jelte, take us away.
All right. So I'm going to talk a bit about this whole thing with AI that if you've been on the internet the past few months, you saw happening, that sort of is taking over the world. Everyone's like, oh, what's it going? What? You can now do everything with AI. You can create pictures. You don't need to paint anymore. You can do anything. You don't need to Google. You can just ask AI and it knows. So I'm here a bit for how can you use this AI for Postgres? What can you do to integrate it with Postgres, and how can you use it in useful ways? And yeah, that's going to be my talk. So the reason I'm doing this talk is because I have one secret problem. I've been working on Postgres with Postgres and on Postgres for quite a few years now. And I still have a very difficult time to write working Postgres queries. I don't know what it is. It's just I forget a comma. I swap around order by and group by, and then it's like, oh, it's the wrong order. It doesn't work at all. I forget how many parentheses I need for a values statement. All of those things can happen, and I don't know. My queries never work first try, and I don't think I'm alone. At least I hope. So in the past, it was always just sort of a given. It's like, oh, okay, I'll just write the query again. But now with AI, I was like, maybe I can ask ChatGPT to help me. So that's what I did. And ChatGPT was like, yes, of course, I can help you. What do you need? And I was like, okay, well, what do you need to know from me what do you need me to tell you for you to help me? And it wanted to know some tables and column names and like the things I wanted to do, of course. So and then I thought that's a bit annoying. Then I have to copy paste my schema from my database or from some file into ChatGPT, so it knows all the tables and the columns I have. And that's another problem I have, although not so secret, is that I don't like doing boring things. And copy pasting schemas and queries, to me that sounds extremely boring. So I thought, how can I avoid this boring stuff? And because Postgres, it has all this information, maybe I can get Postgres to communicate to ChatGPT for me instead of doing it myself directly. And that would need some functionality in Postgres to be able to do that. And that's actually quite possible because Postgres has extensions. It's one of the things that make Postgres quite special with respect to other relational databases. It's actually in the original paper for Postgres in like the abstract that Postgres it's one of its goals is to be extensible. And the way it does that is that you can define your own types, your own functions. And how you do that is by having two parts. You have a shared library, which contains all the native code. So that can do anything, basically. It's like any program running on your computer can make web requests, can do whatever. And then sort of to call that native code from a SQL function or from a SQL query, you define some SQL functions. And those SQL functions are very simple. They're like, this is the name of the SQL function. This is the things it returns and the arguments it takes. And this is the name of the native function that it will actually call internally. And Citus is built like that. Lots of other things are built like that. So I thought, well, let's write a GPT Postgres extension. How hard can it be? And there's one other thing about me. I like Rust. It's like this fancy new language. It's not super new anymore, but it still sort of feels new. All the things about it feel new. It has everything is an expression, so even your if and your else, they sort of return values, and you can do pattern matching, which is it's sort of destructuring of data, of structures and structs and objects, and in sort of a way that it just looks nice in code. And it's hard to explain if you haven't seen it. Just go look at it. And the type system is also fancy. It's like Haskell, but I can actually understand what it does. And it will give you things like not having null pointer exceptions. And on top of that, it's also extremely secure. There's no memory leaks, no double freeze, no data races, none of those things that you're used to from C or C++, and data races can happen in pretty much any language. But even those that don't, if you're doing in the correct way, they don't happen in Rust. And even with all those security things, it's just as fast as C++. And C. Although it doesn't really matter for our use case, because I just want to talk to ChatGPT, and probably ChatGPT is the slow thing in this whole setup. But we can at least send questions to ChatGPT very, very fast. How long ChatGPT takes to respond, that's another matter. And finally, not unimportant, it has a package manager. And C and C++ they famously don't, and managing dependencies, it's horrible. That's kind of So package manager in Rust is good. It's like any other package manager for most languages, but C and C++ they don't have it. And finally, sort of bonus thing, it has this really cute little crab as a mascot. He's called Ferris, so that's bonus points for cute mascots. So I've actually been playing with Rust for quite a long time. I have a fairly popular open source library called Derive More, and it automates writing boring boilerplate in Rust. So you might see some things in the things I work, so some commonalities in the things I work on, where I'm trying to automate all the boring things away. That's kind of what I do. And I actually did this seven years ago. I started with it, and it grew way more than I expected, because apparently other developers also don't like doing boring things. So now it's actually used by more than 100,000 repositories on GitHub. So it's quite, definitely my most used library for sure. So I never used Rust professionally. I only did this sort of as I started doing this at the end of my university, and then I sort of did it outside of work. I sort of continued a bit with it. So that's something I kind of want to change. So how do I combine Postgres and Rust, and maybe even Citus? Because I'm working on Citus most of the time, so I could even sort of pull Citus in to make it more relatable to work, and get Microsoft to pay me for doing stuff on with Rust. And actually, I'm not the only one that wants to combine Postgres and Rust. There's this great PGX library, and I just learned today that in the last 24 hours they changed their name to PGRX. I guess the R stands for Rust. So anything that says PGX in the next slides, it's probably it will be PGRX tomorrow. But I couldn't change my slides anymore in time. But there's a Rust library to build Postgres extensions with Rust, and that's kind of just what I want to do. And it's actually really easy to use. It's a few commands. You install Cargo PGX. Cargo is the Rust package manager, and you can install some plugins to it. So by running Cargo install Cargo PGX, you can then run Cargo PGX in it to sort of set up Postgres extension tooling. And then you can create a new extension. You can do cargo pgx new, my extension, and you go to the directory of the extension and can play around with it. That's in the README of the project. And but that sort of brings us to the next issue. I need a name for this cool new GPT extension. So, I mean, sort of the most obvious one is PGGPT. But it turns out that I wasn't the only one with this nice idea of combining things. So someone else sort of did exactly what I wanted to do. But I already submitted a talk. And I mean, I still think I already started working on it also. So it's of course it's different. Mine is obviously better. But yeah, but I should at least not take the same name. That's just confusing for everyone. So maybe flip it around. Go for GPT PG. And I mean, it's a nice palindrome, so that's kind of cool, but it's kind of hard to pronounce. The only reason that rolled off my tongue so easily because I practiced it a lot. So I ended up at the final choice of PG Human. It doesn't contain GPT, but it sort of brings the idea to you, like, we want to humanize Postgres so that it's not such a machine anymore. It becomes a bit more human. It understands you better. So I double-checked with ChatGPT if it thought it was a good name for the extension. And it was like, yes. Oh, yeah, it's a great name. Short, catchy, easy to remember. So I was like, okay, well, if ChatGPT agrees, I will use this name. So I continued. I changed my extension to PG Human. So now we have a directory. And then in the directory, you run cargo pgx run, and you create the extension inside the Postgres shell, which is cargo pgx run actually spawns the Postgres shell automatically, so you can play around. And then you create the extension, and then it even has a built-in hello world. So you have an extension that works. It doesn't do very useful things yet, but it works. So then I wanted to make some changes because, I mean, I wanted to make it do useful things. So I made some small changes, I recompiled, and then it took 7 seconds to compile. So that's not really, I mean, it's not super slow, but it's slow enough that it annoys me. So I looked into it a bit, like, why is it so slow? And it turns out that one thing that makes Rust compilation and compilation in general slow usually is linking, which is compilers, they create multiple files, and then they sort of merge them together in a final binary that you can execute. And that step, it's done by the linker, combining those files. And the GNU linker, which is sort of the default one that you get on Linux, it's a bit slow. So it's very easy. You can swap it out for a faster one. Molt is fast. LDD is fast. LDD is from the Clang people, and Molt is from someone else. But I tried Molt, and it was like, three lines in some file in my home directory, and then it took only 1 second to compile instead of 7. So that's okay. At 1 second, I think is acceptable. That's fine. My change compile cycle is not impacted so much by that. So now we can actually start. So what do we actually need in this extension? First, we need to get the schema definition. That was sort of the whole point. We wanted to avoid copy-pasting that schema definition. And then we need to send it to GPT because that's sort of the paste part. And then, I mean, we get some query back that we might execute. And we kind of don't want to copy-paste that either. So we just want to execute that. I mean, I'm not going to read it anyway. That's way too much work. So I'll just trust that it sort of does what I want and execute it right away. And then if that query is like a select where you want to fetch some data, that should actually also return that data, not just run and then throw everything away. So we need to sort of return arbitrary SQL results because all the queries I mean, you don't know what kind of query it is. It can have many columns or just one. Yeah. So let's start. And getting the schema definition is actually not super easy. Postgres somehow doesn't have like a built-in way to do this, which is very surprising to me. So, well, it's also not the worst. There's like sort of internal tables from Postgres that you can look at to see what tables exist. And I just did that and looked at the column names and sort of concatenated strings together to turn it into something that looked like create table statements. And then I had like a schema description. And then I need to send them to ChatGPT. And it's very easy to do that. You can install the OpenAI package for Rust, and cargo is this package manager again. So it's like a one-line command, and you have a ChatGPT client that you can send questions to. And then you need to make those questions. So we first start with giving the AI a little bit of confidence. You want it to really give you the good answers, and it only does that if you tell it they're an expert. So they're like a Postgres expert. Otherwise, I mean, maybe they're just saying dumb things, but if they're an expert, then they will never do that. So that's one thing. Then you want to tell it what you have. Like, this is my database schema. That's a second thing you send it to. And then you tell it what you need. Like, I have the schema, and I want you to give me a query that does this normal human description thing. And then finally, also really important, you tell it what you don't want. So you don't want all kinds of fluff around it with things that you don't care about, like just sort of descriptions. I mean, you just want the raw SQL query. That's all you need. And you don't want it to make up tables that don't exist. I mean, the things you're sending it's all the tables that are there. So if it thinks there's other tables, it's like, okay, well, that query is never going to work anyway. So you try to suggest to it that it shouldn't do that. And that's the important part. It never really completely listens. Most of the time it does, but sometimes it just ignores your advice. But yeah, people also do. But there's one issue with sending these requests, and that's that Rust, it loves async and threads to make everything go fast. And async support in PGX, it doesn't really exist. I opened an issue on GitHub to sort of discuss a bit how we could make that better. But at the moment, there's not really a nice solution. And Postgres and PGX really don't like threads. Nothing in Postgres is thread safe. So if you spawn multiple threads that touch Postgres things, everything is gonna go horribly wrong. But luckily, there's a really easy sort of workaround. You can just tell the Rust async library to run everything on the current thread. And then you don't use threads. It won't go as fast as it could, but that's fine. We're only sending one request at a time anyway. So we might as well do it on the current thread. And then we get some query back that we can execute. And then we need to execute that. And Postgres has SPI, which is Server Programming Interface, which is like a C bindings for running SQL in an extension. And PGX has really nice Rust bindings for those C bindings. So it's just as simple as you get a string of SQL and you say execute, connect SPI, and then execute this SQL. That's all you need to do. So this was actually very simple. But the returning arbitrary results is where it gets a bit more complicated, because all you can do with the Postgres extension is create functions. And functions, they need to have a known set of columns. You can't change those columns on the fly or while running the function. Postgres needs to know what columns that function is going to return. So that seems a bit of a problem, but actually it's not so much. We are not running any SQL already anyway, so we're sort of doing NoSQL kind of things. So we might as well go fully NoSQL and start returning JSON blobs. So that's what we're doing. Postgres can transform a query and return one JSON blob. So we have a function that returns only JSON, like a single column with only JSON. And that's kind of, and you wrap the actual query that you get from ChatGPT in like a little bit of wrapper to turn that query into returning JSON. And then you have something that works. So now it's time to show that all this sort of does what I tell it does. So we're going to hope that AI is doing the right thing. But I didn't know really what kind of demo I needed to do. So I asked ChatGPT again. I was like, to-do list app, that's a good demo app. I was like, okay, well, that seems reasonable. So let's do that. I will start typing now. And so the thing I do is let's first create some tables. And as you can see, I'm calling this function. I'm feeling very lucky. So it's this is changing your database with something returned from an AI that might or might not do exactly what you want. So I think it's a well-named function. And what we're going to do is we're creating tables for a to-do app with multiple users. And when I run that, it's going to think for a little bit. And if we scroll up a bit, you can see it created a table with users, and it created a table with tasks. And user ID, description, due date is complete for all the tasks and names and emails. So that looks pretty reasonable. But the due date seems a bit unnecessary. So let's remove that column. We don't really care about it. And ChatGPT happily obliges. It runs an alter table, drop column, due date, even though we didn't specify what table it was, or that there was an underscore in between due and date. It sort of understands what we mean. And if I look at the tables that we have the tasks in the users table. So now we need some data to show some nice queries. And creating dummy data is always quite annoying. You have to think. And ChatGPT can think for us. So let's add 3 famous football players and have 3 tasks for each of them based on their training schedule to have some nice relatable data. And we wait a bit. This usually takes a bit longer because ChatGPT, it creates tokens, and each of those tokens cost a bit of time. But this time it was fairly fast, only 7 seconds. But because this is, it's actually creating quite a bit of data, so it takes more time to generate that than a simple query. And as you can see, it's like it adds Messi and Ronaldo and Neymar. I'm not a huge football fan or anything, but those even for me, those are names that I know. And it even knows sort of the football clubs that they're from and uses those in the email. So it's really nice touch. And the tasks, they also sort of make sense. They look like football things that you could train. So yeah, let's see if anyone completed some of their tasks. If there's any completed tasks, you can check like the public task, and it will create a query. Is complete, is true, but there's currently no one that completed any tasks. So let's change that. Let's add some random. Let's complete some tasks randomly. So we randomly complete 50% of the tasks. And it takes a bit of time, but then we get a query back, update tasks set is complete to true, and then where ID in something, I don't know, so some query with some random part, so that seems reasonable, times 0.5, so that's probably sort of the chance of it happening. So that, I don't know the exact details, but it looks about all right. So let's take a look again at let's show the completed tasks again. Yeah, you can see like, there's 5 completed tasks now. They might not be entirely random because it's like 5, 6, 7, 8, and 9, but maybe, who knows? It could be random. And now we kind of also want to know who's completed these tasks, and we only see user ID 2 and 3, so that's a bit annoying. So let's show the amount of completed tasks by user and include the username, just so that we know what football player is actually doing their training and which one is not doing anything. So we wait a bit again, and we can see that Neymar is clearly the one that's actually training a lot, and Ronaldo is behind. But Messi is just, he's probably old and not. He thinks he's done enough. So we have, and the query, it's actually not a super easy query. It has like a join on like the columns that are actually there, and it does a group by, and it thinks of all these. It does all the things sort of in a way that makes sense. So it's quite impressive to me. And that's kind of the demo. But one final thing is, after demo, I usually like to clean up because I don't like leaving tables around. So they mess up other tests that I do. So let's sort of remove, delete. Let's just delete all the tables at the end. So we drop table and it deletes the tables very happily. So this is one of the reasons why you probably shouldn't do this all the time on your production database. I mean, whatever you tell ChatGPT, it will execute, and it's totally fine. And that was a demo. And so where can you find this amazing Postgres extension? It's open source. I just published it like 5 minutes before my talk. Definitely use at your own risk. It's more toy than production project at this moment. But it's fun to look at. The code is quite easily understandable, I think. That's yeah. And there's a few things that for future improvements or like future fun things to maybe add to it. It's like explain plans, because those are usually hard to understand. Index suggestions, like what columns to index for your queries. And also for Citus, it's like distribution column suggestions is another thing. It's sort of even harder than index suggestions because you can only have one distribution column, and it's not always the primary key. It's you have to do you have to think a bit about your schema and your queries to do something intelligent. That's that was my talk. Are there any? If there's any questions, I'm happy to answer some.
Okay, so that was a delight.
Yeah,
oh my goodness. Okay, so we want to know, did you actually write the code, or did you make ChatGPT write it all for the extension?
So I wrote it all. There were some examples. I know one of my colleagues, Marco. He did use ChatGPT to use PG, like to tell ChatGPT to create some other extension sort of template. So it sort of knows about it seems. So that's yeah.
And you just mentioned Marco Slot, who's giving the keynote talk in the EMEA live stream that's tomorrow, Wednesday. Just throwing in that shout out there. All right, Rob.
Yeah, I loved at the end where you're like, be careful what you tell ChatGPT to do. Earlier when you said like, let's remove the column, and it like drops the column. And I thought like, wait, was he removing that from his select statement, or did he mean from the table? So I'm just waiting for the day when it's our first, like delete without a where clause because of ChatGPT. Like that will eventually be a thing that somebody has to tell their boss, I'm sure. So
yes, for sure. That's going to happen.
On a slightly more serious note, so now that you've kind of played around with this Rust extension, and by the way, thing I learned that they just changed their name like earlier, within the last 24 hours. So I think that's good long term, but interesting timing. I'm curious when you would maybe recommend to folks to use Rust for an extension versus trying to do it in C.
So I actually think it's easier in Rust, sort of for everyone, honestly. I mean, unless you're really like a Postgres core developer, like that works on Postgres a lot, I think it's easier to learn Rust, and even the setup is so much simpler than having like creating an extension in C. You have to do lots of things. You have to look at make files. It's all very annoying and hard if you don't have sort of experience with it. And with Rust, it was a few commands and you had something set up, and there's some examples and that you can look at in the repo. So it's really, I think it was easier to write an extension in Rust than it was in C.
So I know you work on the Citus extension to Postgres. Are you saying that if you were to start the Citus project today, you would be proposing to implement it in Rust?
I think the Citus one might be sort of a special case because it interacts so much with all the Postgres things. So it's kind of useful to be able to copy paste some code sometimes that is not really exposed in Postgres, but we kind of still need. So that, and if you have Rust, you can't simply copy paste C because it's a different language.
the team is secretly writing a bot to just like rewrite the whole Citus extension into Rust like over the summer or something. Like
I don't expect that to happen very time soon. But we're definitely investigating other, like we're definitely using Rust for some other extensions.
Well, thank you so much, Jelte. I know Rob wanted to ask questions about the pronunciation of Postgres.
Yeah, well, I just wonder, can you get ChatGPT to actually call it Postgres instead of PostgreSQL?
I have not tried, but I think if you ask it sweet enough, I think it might. That's kind of it listens most of the time, but so sometimes it has its own free will and does something that you don't want anyway. That's what I've kind of learned. Because even if you tell it like, oh, you don't only want the SQL, the raw SQL, sometimes it still adds like, this is the SQL right in front of it, and then when you execute it, it just doesn't work because that's not the SQL that you want to execute.
Well, Rob, when we look at our checklist, we can check off like discussion about the pronunciation of Postgres, because you can't have a Postgres conference without having that discussion. There.
Somebody's working on their bingo card right now. So yeah.
Thank you so much, Jelte. You are going to be co-hosting the EMEA live stream. So for people who come to that, we will see you again tomorrow. And for those of you who want to mark your calendar, that's happening Wednesday, 9 CEST. And there's a calendar invite URL showing on the screen right now. So thank you. This is awesome.
Yes. See you tomorrow.